Hi, I'm Cressel Anderson. This is Makercise. In this episode, I face off the ram for the Shaper project. I noticed an inclusion on what will become the bottom of the ram, and I wanted to talk about that. Last time you saw me glue an arbor to a styrofoam pattern and then create a riser, and then I put that pattern down into the sand and I poured metal into the cup at the top. Later, I noticed this inclusion, and I'm pretty much attributing it to gases that got trapped inside during the casting process. So as the molten metal filled the cavity, some gases got trapped and created that little pocket. Well, anyway, I went on to clean up the ram and get it ready for assembly. Originally, I was thinking that it was hitting back here in the corner and that I would file or scrape this back corner. However, I got to thinking about it a little bit more, and this is a 20 millimeter arbor that I cast it on, and I have a piece of 10 millimeter stock that I can put in there and tell that, okay, this side of the ram casting is actually pretty close to the center of that 20 millimeter arbor. In the back, however, it's considerably lower. And then I got to thinking, well, I'll check the ram cap, and the ram cap is quite a bit lower, quite a bit off center on the one end, and the other end is quite a bit proud. If I align these two pieces to where the angles are complementary, basically what I need to do is file down this side of the cap so that it fits well. Probably took that a little bit too far, but this is closer, pretty close to half. Probably have 15 thousandths shims on both sides, and that will leave me, I guess, about 24, 15, 9, about 5 thousandths worth of shims, 4 or 5 thousandths worth of shims. So I'm probably going to cut two 4 thousandths inch shims to go in there. That's with a 3 thousandths shim. I think we're going to run with that. I think I'm going to go ahead and call this good enough. The way that I started was using the sandpaper, but what happens is if you get a little bit of rounded edges, which is what I had where the center was kind of sanding, without a really good way to hold it, there's no way to flatten that out. So taking the prints and then either scraping, which is what I started out with, or using something like a rasp, or even a more heavy-duty rasp, will help get it down to a flat surface. Then I was able to scrape. I even sanded a little bit more once I had that bow kind of out of this piece. I went back to sanding, I guess, after I used the rasp, and then after sanding it a little bit more, I went back to the scraper and kind of finished it off. So I think this is probably good enough. So next up is I'll go ahead and mark the center of the arbor as well as the point on the rear of the ram that's going to hold this between centers for turning. The top of the ram arbor at the front of the ram is pretty much zeroed out, but when I go back to the rear, it's about 25 thousandths low. So what I think that would mean is if I face this arbor like the book describes, this face would be perpendicular to the ramways, but the face would not be perpendicular to this arbor. They're essentially a little bit out of plane with each other because this arbor is not parallel to the ramways. And I think that just means that like when I glued this into the pattern, it wasn't quite parallel. I need to turn an arbor with a center that's concentric with the arbor. That'll put a center on this end. I'll also need a center on the back of the ram for facing this, and I'm going to move that center down whatever I face off the front of the ram. That plane will be perpendicular to the axis that goes through this arbor. It won't be perpendicular to the slideways. I'm going to zero that. So that is the top. Then I'm going to subtract off 10 millimeters. So that puts me at the center of this end. Now I know from my math that I need to be 30 thousandths times 4.07. That's the ratio of this measurement to the full length. So I need to be down 122 thousandths of an inch. So I'll switch it over to inches. And then I'll go down 122 thousandths of an inch. Zero that. So this is the measurement that I want to have. Actually here, there is somewhere here that I need to drill a center so that I can put it on the lathe and face off the other end. It actually turns out that this is pretty close to a 1-inch 123 block plus a 3/8 inch piece of key stock, 10 or 15 thousandths low. So what I'll do is I will take these 123 blocks, the shims, which come to about 15 thousandths. These are the shims from the ram cap. And I'll take this, mark it. So this is the height that I want to have my center at. And I just need to find the center of this, 20 millimeters roughly, so 9/8. There you go. Now that I've got my center drilled in the rear of the ram, I am going to turn my focus to turning an arbor to support the end that I will be facing. Just had a little bit of a crazy thing happen. While I was turning this part, it popped off and kind of ended up in behind here. And the reason I think this is the headstock is kind of those little pins that I put in do not seem like they were sufficient to keep the bearings in the headstock. There's too much pressure. I probably need a flange bearing here. The pins really aren't sufficient. I guess they're to keep the bearings from having a tendency to spin. The one on the left side of the headstock seems to be fine, but the one on the right side is the one that really all the pressure is on. during turning. So I think what was happening is it was just kind of scooting back. The surface finish of this part was really horrendous, and then I guess as this part loosened up, you can tell where the tool kind of cut into the workpiece farther and farther until it was able to pop out. So you can tell what happened here is there really just wasn't enough bite in this bearing cap for that pin that's supposed to go in right here to retain it. So it just kind of broke out the side of this bearing cap and allowed the bearing to slip back into the headstock. I really need to replace this with a flanged bearing, but for the meantime, I think I'm just going to use this oil hole to kind of get things aligned and keep stuff from slipping around. Seven, 8, 5, 5. 7, 8, 6. 7, 8, 6. 7, 8, 5, 5. Look at that. Fits like a glove. Oh yeah. Oh yeah, that's friggin' nice. Oh man. I'm facing off the ram for the shaper. I have to lock down the carriage because I don't have enough travel on the lead screw. So I pretty much just have to kind of eyeball it, lock it down using the lock on the rear of the carriage. And what I didn't realize, I was kind of a little focused on getting footage, I guess. I ended up taking off the corners here where it was running into the shims under the tool. When I reviewed the footage after the fact, I thought it was cool that I could see the collision. You can tell that it's rather violent because the workpiece is deforming the carriage out of its way. I faced off the ram, and here at the end I ended up using a pretty large radius, and that's to give it a nice smooth surface finish. One tip is to make your arbor a little bit narrower. You can see I've got a step in it, but I guess I wasn't quite thinking when I cut this to length. This arbor, the shelf there, would be nice if that were back into the face of the ram, and that way I could get this tool bit all the way up to the center of the face. As it is, I was only really able to smooth out to about right there, so there'll be a little bit of a raised portion in the middle of the face, and I'll just hit that with a scraper or something to kind of knock that down, and that way the protractor disc will sit flush against this face.
One of the things you may be wondering is, since I've faced off the ram at an angle relative to the slideways, won't that mess up my ability to accurately cut an angle using the down feed that's attached to the ram? To illustrate why that won't be a problem, I am setting the mismatch to a really severe angle. This is 15 degrees. If I space out 10-degree intervals around the arbor on the face that's perpendicular to the arbor, as well as spacing out 10-degree intervals perpendicular to the slideways, I can project the angle degree markings onto the vertical plane and take a look at the error between those different angles. There isn't any error at 90 degrees, and there isn't any error at 0 degrees. The maximum error happens at about 45 degrees. So taking a look at the 40 or 50 degree angle error, you can tell that it's about 1 degree. And you could calibrate that out with markings on the protractor, but really not too severe. For what I have, which is about half a degree of misalignment between the arbor and the slideways, the angular difference really is negligible. It comes to about 1/1000th of a degree, so I think there'll be other sources of error within this machine that probably will exceed that level of error.
Those of you who are supporting me on Patreon, I really appreciate your support, and I hope you enjoy the extended cut footage where I complete everything in Chapter 2 of the book. I hope this project builds your confidence to exercise your inner maker. Thanks for watching.